In this video, we'll be demonstrating how to add or subtract rational expressions. So the first step of the process is to factor your rational expressions. Now, in our first example, example A, there isn't any factoring that we can do. If you look at the numerator and the denominator of each fraction, you can see that they're already in the simplest form they can be in. So we're not going to factor those, but we will find the lowest common denominator, which is our second step. When you're looking at the lowest common denominator for a set of rational expressions, you have to take a representative of every factor you have, or every polynomial you have, to the largest power that you find it. So, for example, we'll have 4x plus 1, and the largest power we have for that is just 1. So we'll have 4x plus 1 to the 1 power. I'm not going to write the 1 power, it's not necessary. So we'll have 4x minus 1 as well, because that's also found in the denominator of one of the rational expressions. Now those are all the factors we have in the denominators for our rational expressions. So together they will make the lowest common denominator, putting them together. And then what you want to do is you basically want to recreate your two fractions with this common denominator. So I'm actually going to write it down twice, 4x plus 1 and 4x minus 1. And now I'm simply going to ask myself a simple question. And that question is, what did I multiply 4x plus 1 by to get it to look like this denominator? Well, you can see we already had a 4x plus 1 here, so we multiplied it by 4x minus 1. So 4x minus 1 is the new piece. That's what I'll need to multiply the numerator by then. So I'll multiply 4x minus 1 times the numerator, which is 2x minus 1. All right, so repeat the same logic for the second fraction. This denominator of 4x minus 1 has been changed so that it has 4x minus 1 times the new piece, the 4x plus 1. So the 4x plus 1 is the part that's been added. So we're going to put 4x plus 1 on top so we can multiply by the original numerator, 2x. Now again, if you notice what we've done then, we've basically multiplied our fractions by a clever form of 1, right? Since in both cases, the original fraction has only been multiplied by something over itself, we've really just multiplied the fractions by the number 1, which is okay because that won't change the value of the fraction. So we've rewritten our fractions. Now we're going to keep the common denominator of 4x plus 1 times 4x minus 1. And we're going to simplify the numerators and combine like terms. So let's start with the first piece here. 2x times 4x is going to give you 8x squared. Then we'll have 2x times a negative 1, which is negative 2x. Then you're going to have minus 1 times 4x, which is going to give you negative 4x. And then, of course, negative 1 times negative 1 is plus 1. Continuing that numerator, we're going to have a minus sign in front of the product here. 2x times 4x is going to give you 8x squared. Then we'll have 2x times a positive 1, which is plus 2x. Now I'm going to distribute in that negative sign to each term. So I will have 8x squared minus 2x minus 4x plus 1 minus 8x squared, because the negative here will distribute it into negative 8x. And then negative times positive 2x is going to give you negative 2x. Draw your fraction bar and rewrite your 4x plus 1 over 4x minus 1. Don't FOIL your two binomials in the denominator of the fraction. If you do that, you might find that you have to refactor it to cancel at the end of the problem, because our last step is going to be to simplify, so you really should only expand the top part of the fraction, not the denominator. All right, so let's cancel now the things that are alike. We have positive 8x squared canceling with negative 8x squared. And then it looks like we have a few terms here that can go together. We have negative 2x, negative 4x, and negative 2x. Together, that's going to make a total of negative 8x, and then we'll have plus 1. So minus 8x plus 1 is our new numerator. And in our denominator, we'll have 4x plus 1, 4x minus 1. And there's not much we can do here other than to leave that as it is. We cannot factor the negative 8x plus 1, so we really should just leave the fraction as is. I personally like to write the positive numbers first. I'm going to do 1 minus 8x over 4x plus 1, 4x minus 1. And we can leave it just like that if we'd like. All right, from here, let's take a look at our second example here, example B. The first step of the process is to factor your numerators and denominators for your rational expressions. So the numerator is simple, 2x. We cannot factor that, but we can factor this denominator, which is the difference of two squares. I'm going to write that as x and x plus and minus 4 and 4. From there, I will have the second fraction. The numerator remains the same, but we can factor again that denominator. So let's factor that. We'll have x squared breaking up as x and x. The plus sign here in the back of the trinomial means we'll have two of the same sign that we have on the left, so it'll be two negatives. And then we'll be looking for factors of 12 that add to 7. Well, what factors of 12 would add to 7? I think 3 and 4 will work for us there, right? Because 3 times 4 is 12, and of course, -3 and -4 give you -7. All right, so we now have the denominators factored. Now we can see what they're made up of. And now to find the LCD, we simply have to say, okay, let's collect a representative for each factor, and we'll take the highest power we see on any particular factor. It looks like all the factors are to the power of 1, so that should be easy. We'll just have to take a representative of each unique factor we have. So we have x plus 4, we have x minus 4, that's different from x plus 4, and we have x minus 3. Now I don't need to write down the x minus 4 again because this x minus 4 is already represented here. So that's our LCD, so I'll write both fractions with that common denominator. So x plus 4, x minus 4, and then x minus 3. Okay, from here, we're just going to observe what's alike and what's different from each denominator. Let's start by putting the numerators down as they started. So 2x for the first fraction, and we have 2x minus 7 for the second fraction. But now if we notice that x plus 4, x minus 4 is here in the denominator, the new piece then is x minus 3. So I'm going to multiply the top by that new piece because the bottom was multiplied by that new piece. Let's do the same with the next fraction. Looks like that fraction has x minus 3, x minus 4. So x minus 3, x minus 4 is here. So the new piece is the x plus 4. So I need to multiply the numerator by that same piece. So x plus 4. Let's rewrite this pair of rational expressions with their common denominator. And let's expand and simplify the numerator. So 2x times x is going to give you 2x squared. And then 2x minus 3 is going to give you negative 6x. Then we'll have a minus sign. And then 2x times x is going to give you 2x squared. And 2x times a positive 4 is going to give you plus 8x. Then you'll have negative 7 times x. That'll give you negative 7x. And lastly, negative 7 times 4 is negative 28. All right, from here, what you want to do is distribute in the negative sign. So I'm going to rewrite our fraction, continuing up here in the upper part of our screen. So I'll have in the numerator 2x squared minus 6x minus, so it'll be minus 2x squared. Then a negative times a positive 8x is negative 8x. A negative times a negative 7x is a plus 7x. And lastly, a negative times a negative 28 is a positive 28. All that over your LCD. Just to be lazy, I'm going to write LCD here so I don't have to keep copying that denominator that's just going to keep carrying on. So let's look at our numerator. Let's combine like terms and cancel what we can cancel. So it looks like the 2x squared and the negative 2x squared will cancel out. Looking at this pair of x's, we have negative 8x and positive 7x. It's going to give you a negative x. If you combine that with a negative 6x, you're going to have negative 7x. And then we have plus 28 left standing, so plus 28. And all of that will be over your LCD. All right, from here, I'm going to factor the numerator. It looks like I can take out a negative 7. So if I pull out a negative 7, I'll have negative 7 out in front. If you divide negative 7x by negative 7, you're just left with a positive x. If you divide 28 by -7, you end up with a -4. And then all that will be divided by our denominator, which is x plus 4 times x minus 4 times x minus 3. Now at this point, the x minus 4 can cancel with the x minus 4. And so that's why we try to factor our numerator at the end in order to reduce. So our final answer is going to be -7 over x plus 4 times x minus 3. And that's the final answer.